Hello and welcome back to Idiot with a Soldering Iron. Today, let's make a speed controller using the bare minimum of components. I currently have 6 components laid out here on the bench. We've got a 555 timer, a capacitor, 0.1 microfarad. We have a 10K resistor, a 1.2K resistor, a 200K potentiometer, and an IRF 540N MOSFET. It's an N-channel MOSFET. So we will be switching the negative side of our motor. If it was a P-channel MOSFET, we would be switching on the positive side of the motor. This MOSFET here is a 100 volt 33 amp N-channel power MOSFET. Basically it's used for any type of heavy duty switching applications. It's primarily used in audio amplifiers, but today we are going to use it as a speed controller using pulse width modulation from the 555 timer. So these 6 components, we're just going to throw them on a breadboard and we'll see what we can do with it and see if we can't drive a big old motor here. We got, I remember if you guys seen videos where I was talking about building a powered sweeper from using some motors I got for some weed eaters, and we're going to use this to drive the sweeper element, the brushes. I've got 2 rotating brush assemblies that I can belt drive, and we're going to use this so we can control the speed here. So let's get the breadboard out, get this breadboarded up, and see if we can't get it to work. Alright, we got our breadboard here. We got all our components thrown up here. So let's go ahead and just start with our basic 555 timer in astable mode. So we go ahead and throw this on here. It's already got our power and ground already connected. We are going to take and connect pin 2 here to pin 6. We are now going to take our trim pot. This is going to adjust our pulse width so we can have a longer or shorter pulse duration, therefore driving the MOSFET here faster or slower. The more on time versus off time, or the duty cycle, the higher the duty cycle, the higher the RPMs of our motor. So now we've got our little capacitor here. We're going to put the negative band here on pin 1 over to pin 2. Pin 4 is our reset line. We're going to pull that high. We do not want this resetting. Pin 8's our VCC, pin 1's our ground. So now we're going to take our 10K, we're going to use that for our pull down for our MOSFET. Our 1K is just to protect our 555 timer, so we don't try and source any more current than needed. Just keeps everything nice and regulated. Now on our MOSFET here, we've got our gate pin. This is what we use for switching the MOSFET on and off. We have our source pin that's going to source our negative voltage rail, and then in the middle here we have our drain pin that is going to drain from the negative rail to the motor. So we'll go ahead and pop that in right there. Now if we go to drive any significant current, putting a load on this motor, we will be required to put a heat sink on this. If not, you getting some current flowing through this MOSFET, it's going to overheat and let the magic smoke out. Alright, now we also need on our gate pin, we need this 10K pull down resistor. Basically what this is going to do is prevent our MOSFET from being stuck on an on state. So we will just bring this over here to our ground rail. It just makes sure that our MOSFET turns off when this driving signal is shut off. And that's it, guys. That's all there, right there on the breadboard. Let me move this jumper over so we are syncing our current. Oh, we are not syncing, we are sourcing our current from the negative rail. Tweezers. Bump you in the face. In the face. Alright. We're over. Yeah. These are actually just component leads that I've clipped off that I'm using for jumpers. Work great for jumpers on a breadboard when you can get them to cooperate. There we go. And we're just gonna go to the ground. There we go. Alright, so I guess now we need to break out our scope and take a look at what our output is doing. So we'll go ahead and got our scope grounded. We're gonna go to pin 3. And get our scope all set up here, looking pretty. Alright, now I'm gonna have to cut this and we'll move over to a scope. Alright, so now as you can see, we got our nice square wave there. Now if we take our little screwdriver here, we're at about 50 hertz. So if we turn our little pot here, we get more and more off time on our duty cycle, to where then it's nothing, it's off. Now if we increase the potentiometer, you can see our duty cycle is increasing more and more on time versus off time until we're solid on. Bringing it down, bringing it down, bringing it down. Slower, slower, shut off. So go ahead and keep her there for now. Let's move our probe over here to the output, or the drain of our MOSFET. Oop, lost our ground here. I gotta figure out a better ground situation. I ain't got enough. Here we go. This will work. Alright, now we got our ground back on our probe. Now let's go ahead and increase. And as you can see in our output, we're getting more and more on, more and more on, all on. More and more off, more and more off. That's it, guys. There is our speed controller. Now let's hook a motor up to this and see what it does. We've seen it on the scope. Now let's see it in the real world what it does. So let's get the motor, get it all hooked up, and we'll get right back with it. Alright, now this is probably going to be a little shaky. I'm just going to hand hold it. But now that we've got our motor in line, hooked up to our MOSFET, we need our screwdriver. There it is. Alright, now we're going to increase. And we got motor spin. Faster, 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 faster. Full speed. Slow, slow. Very nice, very nice. More. That's a 40 volt motor running on 12 volts. So eventually, now we can look here on our scope. We're looking at the output of the MOSFET here. Yeah, we got a longer duty cycle change in here. Forward, all the way on. Slowing her down, lowering the duty cycle. And we're done. That's it, guys. 6 components and we can control the speed of a DC motor with ease. God, I love 555 timer.